Hello everyone, welcome back to the channel. I'm Chandan. In previous video we saw about inverter analysis for varying input signal slope and for different load. So if you guys haven't watched this video, I would have provided link in the description. So coming back to today, so we'll be having a look on ModelSim debugging. So using breakpoints, step into and step over commands, we shall slowly look into these elements. How do we utilize these elements and effectively debug? First things first, we should ask ourselves, why do we need something? So debugging, like why do we need debugging? So when the design is smaller, it's quite easy to figure it out, like the fault which you have committed in the code. So however, when the design turns out to be complex, it becomes so almost impossible to figure out the fault. That is usually we commit the logical errors because the syntax errors are flagged by the compiler itself. So when the design is quite complex, also it becomes quite hectic or to trace out manually and check for the correctness. So what the conclusion is, like for complex design, debugging is very much essential, and also debugging save lot of precious time which is involved while developing. And the secondary benefit is also that debugging also helps us understand our code's logic and also the flow of that code in a better way. So these are the elements which are present while debugging. So we shall learn each and individually. So breakpoints. So breakpoints are kept in the code to break the flow of the execution up to this point. So when simulation hits that point, it is indicated by a blue arrow in the source view, and also there is a message in the transcript window. So and also you can traverse a breakpoint to a breakpoint, which also make sure they will be skipping certain number of lines which is not our interest. And we should also make note that breakpoints can be set only on executable lines which are indicated by the red line numbers, and the blue arrow indicates that the breakpoint has been hit by the simulator. And the different commands which are present are step into and step over. So the use of step into command is that this, when we click over this icon, so the debugger single steps the code, the line of code. And the usage of step over is that if a line of code contains a function or a task, it will be executed and the result will be returned without debugging each line, because we are not interested what exactly is happening inside the function or task, but however we need the results out from that, so that the further line of code would have dependent on this data. So this is the project flow. So we shall create a project, we shall add the files to the project, we shall compile and run simulation and debug the results. So the first design we'll be taking is the full adder. So and the full adder code is written using behavioral modeling style, and for convenience of flow, debugging flow, we have written the Verilog code and the test bench code in the same file. And this is the truth table of a full adder circuit. Now we shall go to ModelSim and learn how to debug. So I've already created a project and also added a file. So I've written the test bench code and the Verilog code in a single file, that is fulladder.v. So this is the Verilog code and the corresponding test bench for that code. So we'll try to simulate now. This is a proper working code which I have written on already. I have tested once. I shall start a simulation. The flow is that we go from the test bench to the design file. So either we can keep a breakpoint and run up to this point, or you can right click and there is an option called run until here. So we can clearly see there is a blue arrow mark which has been present, which shows this is a point where it has stopped. So I'll be using this step into command. So since there is a changes in A, B and C, so $monitor will be executed. Now the flow has been taken to the Verilog code because there was a change in A, B and either one of them there was a change, so that this block gets executed. So I'll again step into, so it entered inside this always block. So sum, which is now we know that ABC values, we'll get to know the values of a register or a net when we hover the mouse over that register or net. So we will be able to see that A as a value 0, B as a value 0 and C also as a value 0. So obviously the sum should have a value of 0. So once we are able to see that sum has a value 0. Now it has gone for the another case. So now A is 0, B is 0 and C is 1. So again there was a change in C value. So this always block gets triggered, the control went inside. So now A is 0, B is 0 and C is 1. So obviously we will be expecting sum to be 1. So after executing this line of code, so the sum is 1, which is right. So in this way, like it will be executing for each and every case. So this is how the debugging works. So now we shall deliberately introduce a logical error and see like how debugging helps us like to figure it out, that error. We shall save it. I'll end this simulation. I've done the changes. I have to compile. So I have deliberately introduced a logical error here, and see how debug helps us to figure it out. So I'll start simulation. So the flow starts from the test bench. So I'll click as run until here. You can do either in this way, or you can keep a breakpoint and you can click on run all or run, any one of would do work. So the breakpoint has been hit, it is indicated by the blue line. Next I will I'll use the step into command. So now A, B, C got those values as 0, 0, 0, and it will go to $monitor. Then since there is a change in A, B, C values, so always block gets triggered and it enters inside. So when A, B and C are 0, 0, 0, obviously the sum we would be expecting is 0. See, we are able to see that we got a sum as 1. So we are able to see that there is some problem, there is some error in this line of code. So if we look at the expression, obviously it should be not a negation of A, it should be just the A. So we will be able to figure it out where there is an error in particular line of code. Then it narrow down where exactly the error is. So now we have made the changes, we were able to figure it out where exactly was the error. So the lesson wrap up is that we learned how to use the breakpoints effectively, and how do we utilize this step into and step over commands, and we understood the flow of design. Then we understood how to observe the various intermediate wires and register values. So after necessary changes we were able to fix it. So thank you.